All right, continuing on with section 7.3, part A, we're looking at these problems in example 2, and it says identify the similar triangles, then find their measure. So if I go through, a lot of times identifying similar triangles, I'll work this visually off a graph if it's not specified that I need to give the reason why, and kind of talk through. So what I notice on this first picture is I have two pair of corresponding angles that are congruent. So it's definitely angle-angle similarity, but I'm going to make my similarity statement. Triangle XZY is similar to triangle JLK. All right, now I know I can set up proportions. So I'm going to look for the one piece where I have known values on corresponding sides, which is on this one where I've got the 20 and 10. All right, next thing I'm going to look at is I'm going to look for the one that has the variable on it, all right, which is the JL, and that corresponds to the 13. So when I set this up, I'm going to go from small triangle to big triangle or big to small, it doesn't matter. But the 10 corresponds to the 20, and the 13 corresponds to the x. All right, so if I cross multiply, I've got 10x equals 13 times 20. Divide both sides by 10, and I get x equals 26. And again, feel free to grab a calculator. I left my top multiplied out here so I could reduce 10 into 20 is 2, 2 times 13 is 26. But again, do what you need to do as far as getting those values. If you need a calculator, definitely feel free to go grab one. All right, if I go to the next one, what I notice is it looks like in this one, I have some comparable setups on the sides. So I've got the 26 and the 13 down here. So this full side here is 39. All right, and on the other side I have congruence marked as well. So this full side is 39, and these pieces are 13 and 26. So what you might find handy on this one is to pull it out into two triangles. All right, so I have G, W, H with a 26, 26, 20. And I know that I have this shared angle up here that I'm working with. Then I have the big triangle, which is GUI, and that would be 39 on both of these sides. We have that shared angle up at the top, and then we have an X on this side. All right, so when I look at this, I know 39 to 26 is 3 to 2. So I have that consistent ratio on two pair of corresponding sides, and I know the included angle is congruent. Therefore, I have my side angle side similarity rule, so I can go ahead and set up proportions. So again, I'm just going to take a pair of corresponding sides where I know both things. So 26 to 39 equals, and then I'm going to take the corresponding sides that have the variable, so the 20 to x. So now I'm going to cross multiply. I've got 26x equals 20 times 39. Divide both sides by 26. All right, and when I do this one, I can, let's reduce a 2 out of each of these, so that's a 13 and a 10. All right, 13 goes into 39 3 times, so I've got 10 times 3, or 30. All right, and again, I'm just kind of giving you some of the, like, how I work through the numbers in my head, but feel free to grab a calculator and work through them on a calculator if that's easier for you. It's just sometimes if you see these little tricks, they can help you with some of that mental math as well. Moving on to the third one, why don't you go ahead and pause the video, give number 3 a shot, all right, and then when you're done with number 3, on pause, and we'll walk you through it. If you feel like a little bit more of a challenge, go ahead and try in 3 and 4 right now if it's seeming easy to you. Pause me, and then when you're done, come back and take a look. All right, so you just took a look at these two. So this first one, if I take a look at it, I've got some information lined up here. The picture, let's see. We've got two triangles that are there. It does not specify parallel sides. All right. We do have 36, 36, and 25, or 36 root 2. And then we have the 24 on the inside. And then they ask us for an X for the little segment that's there, which would correspond to this side over here. So first thing I'm going to check is I'm going to check and see if I actually have enough for similarity. One thing I know for sure is I know that I have the shared angle. All right, so I have one angle. All right, I only have one side on the small triangle that I'm going to highlight in green for you here. All right, I only have one side on that triangle, so I can't use any of the side, side, side or side, angle, side because they're out of luck. So with only one angle and only one side, I actually don't have similarity here. So without making an assumption, I can't show that these are actually similar triangles. All right, so I'm going to go ahead and write on this one, not enough info to guarantee similar. All right, now, if you made the assumption of parallel lines, which is what they were probably intending with this one, all right, that these two sides are parallel, then you could go to angle, angle. And if you did that, what you'd end up with is we're looking at 24 to 36, right, is that ratio of the side. So if I go to the other one, we'd have RS to 36 is the same ratio, which would give us RS is 24. So we'd have a 24 there. And then you've got 36 minus 24, which is 12. So this little piece in here would have to be 12. So the x would be 12. But again, in all technicality, they didn't give you enough information to do that based on the picture provided and the information provided. Now, when I go on to the next one, all right, this one they actually did give you enough information. It's just kind of subtly hidden. All right, those two parallel markings are going to give you the angle you need. All right, so we know those two angles are congruent. We also know those two by alternate interior angles. That means we have triangle ACB is similar to triangle DEB. And again, I went one tick mark to two tick marks to no tick marks, just as kind of a way to work around it. All right, next thing I'm going to do is I'm going to look for sides that I know are corresponding, and I have values for both. So I have the 30 and 60 for those outsides, so 30 to 60. All right, and that's going to equal the ratio on the other sides, and I have this x here. Now, the x is on BC, so I always check back to the similarity statement. BC has to correspond with EB. All right, so that x is going to compare to a 38.6. Now, 30 over 60 is 1/2. All right, so I've got this set up. And from here, I'll basically just cross multiply, and I'm going to get 38.6 equals 2x. Divide by 2, it's going to be a 19.3. All right, so my x value is 19.3. And again, we technically used angle-angle similarity from the parallel lines to get our similarity statement, and then we used that to set up our proportions. All right, that takes you through the second part of 7.3. 7.3 tomorrow, we're going to look at more practice with these and setting these up. So tonight's homework's all about getting kind of this general idea down, and then we'll refine it tomorrow. All right, hope that video helped. Have a great night.